Some products. Kind of developed this tick over the last 2 years, and I'm trying to figure out what to write. Start doing this. That usually means, this means money in Turkish. Give me a lot of money. This means money, please. Some product of the payouts twice. It's so nice we multiply it twice. Okay, movie reference. Where did you hear that before? It's Penguins of Madagascar. Take the square root. Of course, when you're civilized people, you actually write a VBA function to make all those calculations. You say, I'm going to give you the range of the values of the random variables and the probabilities. Calculate me the expected value in units. And VBA function is going to spit out both of them. But that's for civilized people, right? Now, here's the expected risk, or the risk, 38 versus 15. If I had done this for 20 people, I'm going to tell you exactly what's going to happen. That risk is going to go down by a factor of square root of 2. I don't have to do it. You can do it as an exercise. And typically, the risk is proportional to the square root of number of clients. So as the number of clients goes up, that risk is going to go down to 0. You know, the difference between 1 million and 10 is that's the factor. Take the square root of that. And the risk that I would have calculated for the average payout for a customer pool that has 1 million clients, it's only $123. So if you think about it, at that point, that distribution is going to look very much like a normal distribution, because binomial distribution converges to normal distribution as you increase the number of observations, but also decrease the probability of event happening. So that means your risk is 13,485 plus or minus, let's say 3 standard deviations, 122. So when I'm charging you, I'm going to add my risk premium factor to, if I have only 1 million. I should charge you at a minimum plus 3 times that. Again, I'm not worried about any risk, any time value of money issues, because you may be dying in the middle, yada, yada, yada. But let's just say, if you die, you're going to die exactly 1 year from today, and there is no interest charge. So if I divide it by monthly, I would charge you $1,154 as 68 per month for $1 million policy. As a 40-year-old, let's see what would happen to that premium for a 1-year term. Where are you? 40-year-olds. Let's actually take that. I'll send you guys home right after this. A 40-year-old will pay less than $200. Again, that has to do with the ratio of the debt probabilities. When we do this for a term policy, we're going to have to figure out exactly when the debt happens. So it's a little bit more complicated, so I'm going to do that on Tuesday. But then that looks like the life of a multi-year bond, right? That you have coupons, and that happens in certain intervals. Depending upon when that happens, that value changes. Because if the company defaults 1 quarter after the bond is issued, there are a lot of interest payments that are missed, versus company defaults 2 quarters before the maturity. And probabilities of those are also different. But technically speaking, it's just a term life insurance concept. Only the nature of cash flow changes a little bit, but we know how to handle present value and other stuff. All I have to do is take that and translate into that. That is the beauty of, that is mathematics. Okay? Mathematics is reducing the problem to something you know how to do. By the middle of Tuesday's class, given a mortality table, you will know how to get a valuation for a 10-year term life policy, given a mortality table, including the risk. For risk of the small pool. The risk of the pool with 1,000 people is different from risk of the pool with 20 million people. Either way, once you know that, you can price a multi-term bond that is subject to default. Remember, default is debt of a bond. And we know exactly what happens when that happens. You get a certain recovery. Okay, that is subject to a probability distribution too, but in undergraduate level, I'm just going to wave my hands over that. If this was a graduate class in defaultable bond pricing, we would actually do a Monte Carlo simulation over the distribution of the recovery ratios. It doesn't matter. If I know what the recovery ratio is, I can calculate a value. A Monte Carlo simulation says the following. Draw a number from that recovery distribution. Given that number, calculate what the value should be. Do this a very large number of times and average those valuations. Okay? Also, you could do a distribution and price it based on that. But other than that, it doesn't matter. And it's very simple. I mean, drawing a distribution from normal, drawing a random variable from a normal distribution is very simple. You do norm sinv rand. That's a draw from standard normal distribution. If you know the inverse cumulative distribution of a probable distribution, or it's also called the quantile function, you can draw from that. In fact, you can start with the quantile function and go to the distribution yourself. I'm actually doing a paper on that myself. It's rather nice. So have this in mind. We're going to extend this to multi-year policy, and kind of as a bonus to you, I'm going to show you how to price something called a death bond. You guys know what a death bond is? This is the dark side of the financial engineering. It kind of got started when AIDS first became an epidemic. There were a lot of people who had term life policies, and they contracted AIDS. Back in mid-'80s, contracting AIDS was pretty much a death sentence. But there was no Obamacare. It also came with a lot of bills. And one savvy financial engineer went to these people, okay, you have a term life policy that's gonna expire 8 years from now, but it is unlikely that you're gonna see 1987, all right? What if instead of waiting 2 years and get your kids getting the money after you die, what if I say, I'll buy that policy off of you? I'll keep making the premium payments, but when and if you die, I'm gonna collect the death benefit. For that, I will give you something. Of course, to fund this, I issue a bond backed by those policies. Those are called death bonds. euphemistically speaking. All we need is a mortality table to price the death bond. And actually, those things have a place in your portfolio because it's a risk that is completely uncorrelated with the overall market risk. So if you have a portfolio that is already diversified, it's going to make it even more diversified. And it's going to pay a expected yield that is above the treasuries. So you get a bump in terms of expected. You also kind of tend to reduce your overall risk of your portfolio, which is something you want to do. But the mathematics is exactly the same. You're basically pricing a term life policy. That's it. All right. I'll see you guys on Tuesday. I'm almost done with your homework assignment for bonds. It's going to be up late tonight. You'll have enough time to do it. Don't worry about it.